for this unit are the following three. And the first one is to learn what a function is and how to identify domain and range. And that's what we'll be working on today. The next one is to be able to identify transformations of a parabola from the equations, and also to be able to sketch the graphs of the parabolas using transformations. So those are the three main goals of this unit. So let's look at, first of all, our goal for today, and that is to identify functions from a table, a mapping, or a graph, and use function notation to represent the equation. So quite a few different things going on today. So the first thing we're going to look at is exactly what is a function. Now, a function is a mathematical relationship that can be represented on a graph where each x value only has one y value. So that's the main thing there, that each x value only has one y value. Okay, so as we go down, and my computer froze, there we go. And as we go down here, and we'll look at it a little bit closer, the function that we're interested in, the most basic function, is going to be y equals x squared. And if you remember from last year, this is a parabola. So first of all, let's look at a few different things. The first thing that we're going to look at is from a table of values. Now I can do this a couple different ways. I can actually enter this equation into my graphing calculator and get it, which might be the fastest and easiest, or I can literally just take -4 and put it in for x, which we can do as well because most of us do not walk around with a graphing calculator. So when I put -4 in for x squared, -4 squared is going to be equal to, and we'll just get our writing utensil here so we know that that's 16. -3 squared is 9. -2 squared is 4. -1 squared is 1. Obviously 0 squared is 0. And 1 squared is 1. 2 squared is 4. And 3 squared is 9. And 4 squared is 16. Now when I look at these numbers, I can see that for each x, there is only one y. Okay, so there's only one y per x. So that's using a table of values. So I can check very quickly to see whether something is a function by looking at its table of values. So as long as each x value only has one y, I can say it's a function. The other way is mapping. Now mapping is a little bit different. It's very similar to a table of values in the sense that what we can do is we can also have our values over here. So for instance, if I'm looking at my y values that I did for my table of values, I can see the numbers that I do have are the numbers such as, and we'll do 0, 1, oops, that is not working very well for me, 1, 4, 9, and 16. And what you do with mapping, it's like, again, very similar to the table of values in the sense that when I map what goes with -4, well, it is 16. What goes with -3 is 9, 4, 1, 0. So you can see it's very, very similar to what we were doing before. So they map into them. That's why they call it mapping. And for some reason, my writing pen doesn't want to do what I want it to do. All right, now I still have the positive ones to go through. So this one is going to be 1. This is going to be 4. And if you notice, it looks a little bit messy, but that's okay. What we're going to look at when we're finished is I want to make sure that no x value has two choices for the y. So it only has one choice for the y. So this again tells me that this is a function. The last way that I can tell is if I have a graph. So right now I don't have a graph, so I'm going to create it. And if I actually do the one that we have, and if I take my table of values, I can very quickly 4, and then I have at 3, I have 9, which should be here. And again, it's not too bad. I think I missed one, did I? No. So there are my points, and now I'm going to draw as best as I can my parabola. And the way I can tell from a graph whether something is a function is what we call a vertical line test. So I'm going to create a vertical line, and I'm just going to create mine this way. And a vertical line test means that if I take this line and drag it across my graph, the vertical line only touches the graph in one location at a time. And you can see that's what happens as I make this vertical line go across the graph. It's only touching the graph in one location. So that tells me that it's a function as well. So reiterating what exactly a function is, these are the three main points that we look at. First of all, the x values don't repeat in a table. So there's one set of x values. In a mapping, there's only one arrow leading away from each x value. So you notice there's only one line going away from each mapping. And from a graph, it passes the vertical line test. So that tells me what exactly a function is. So the next thing we're going to look at is what we call, is we're going to talk about some examples. So we're going to take a look at, first of all, what happens if it's not a function? What will that look like? So again, we're going to take another mathematical equation, and this time it's going to be x equals y squared. So in a sense, we're doing it backwards. So if I have -4 for my y value, what are the possibilities that I could have for my x? Well, when I take square root of a number, it could be the positive or negative of it. So in a sense, what's happening here is the square root of 16 could be -4. The square root of 9 could be 3. The square root of 4 could be -2. The square root of 1 could be -1. And the square root of 0 obviously is 0. Now, watch what happens here. I could have the square root of 1 could be +1. The same thing with 4, 9, and 16. Okay, now sorry it's a little bit messy because I am actually doing this at home using either my mouse or my writing pen. So again, when I look at my x values for my mapping, what happens is I have the numbers 0, 1, 4, 9, and 16. Okay, now you can see, remember I told you what a function is, that for each x, I can only have one y. You can see that doesn't work here because when x is 16, it could be -4 or it could be +4. So I have 2 right there. Now from my mapping, and this time I'm just going to use the black arrow. So when I look at 0, well, there is only 1 for 0. But if I look at 1 for my x, it could be -1 or it could be +1. The same thing is true for 4. It could be -2 or +2. So if you noticed in comparison to our last function, to the function we had in the previous page, this time the x has 2 arrows coming from it in most cases. Not all cases, but in most cases. 9 we have -3 and +3. 16 we have -4 or +4. So you can see the 2 arrows going from each x value. Now again, if I go to graph this function, I can either use the table of values. So I have 0, I have 1, I have 4, and I have 9. Oops, sorry, I did that wrong. I have 1, which is right. At 4, I have 2. And at 9, I have 3. Okay, so you can see that what we have created here is actually looks like a parabola on its side. Okay, and it does go on. We just haven't done that. Now, if I look at my vertical line test, does it apply here? Well, let's take this vertical line again and see what happens. You can see as it goes over, at one location it's only 1 at 0, 0, but as I go across, it's cutting the graph in 2 locations at one time. So that tells me it is not a function. So types of examples that you would be expected to do. So the first ones tell us, pick out the functions, and if something is not a function, explain why you say it's not. Okay, so the first one is a graph. So if I have a graph, I'm going to use a vertical line test. Well, the reason this is not a function, you can see right away it's not one, is because it cuts the graph actually in more than 2 places, in 3 places in this case. Okay, the next one I'm going to look at is the mapping. Remember from mapping, if it's a function for each x, there's only one arrow going from it. Well, 4 to 7 is one arrow, but this one doesn't apply, and neither does this one. So that tells me it is not a function. When I do the next graph, I also can see that I'm going to use the vertical line test. And this time when I go across, I can see it only cuts it in one place. So that tells me that it is a function. The next one I want to look at is a set of ordered pairs. Now, if these were in a table of values, it'd be a little bit easier to see. But here I have a 2, a 4, a 3, an 8, and a 9. So I only have one x value for each one of these ordered pairs. So that tells me right away it's a function, given that information. If I look at the last mapping question, when I look at it, again, I'm looking at my x values to see if there's more than one arrow going from one x. There isn't, so that tells me that it's a function. Okay, so that's the first part of our lesson today. The next part is on function notation, which you'll do also.